Hello everyone, I'm Shweta, Assistant Professor from AI&DS Department at Kalanya Karunanidhi Institute of Technology, Coimbatore. Today we are going to learn about skip list. What is skip list? It is a advanced data structure that improves the efficiency of searching in the linked list. In a normal linked list, to find an element we move step by step through the every node, which can be slow. A skip list solves these problems by creating additional shortcuts layer on the top of the list. These layers allows us to skip over many elements at once, making the search process much faster and often close to the speed of binary search. Why we using the skip list over linked list? In a linked list, searching, inserting, or deleting takes linear time on because you have to go node by node, right? A skip list adds a multiple level of links. Think of them express lanes on a highway, so you can quickly jump ahead instead of shopping at every point, right? This reduces the average time complexity for operations to O of log n, which is much faster, right? Where are skip list used? A skip list are used in many practical applications where quick searching and updating the data is needed. They are found in database memory caches in Redis and searching engines to store the data efficiently. They are great balance between the simplicity of linked list and the speed of more complex data structures like balance trees. And so the skip list simply a linked list with extra fast lands, making our operations much quicker and more efficient. Let's now look at the definition of skip list in detail. A skip list is a data structure designed to make searching, insertion, and deletion much faster compared to normal linked list. In a single linked list, you move one step at a time, but skip list adds something extra, multiple layers from the linked list on the top of each other. Here, how it is work. The bottom layer is just like a normal linked list. Then above it we add a more layers, and each higher layer connects fewer nodes, and these higher level act as a express lands. They let us skip over several elements on the jump. So we when we search for something, instead of checking every single node, we move quickly across the higher level of and then drop down into the lower level when only we need it. That's why it's called a skip list, because upper level skip over nodes. This means much faster traversal access. In simple words, it's like having a shortcuts built into your linked list, so you can reach out the destination quickly. And the next thing is, why do we even need a skip list when we already have a linked list? The main reason is speed. A normal linked list is slow for searching because you must check each node one by one. But skip list is designed to much faster because it lets you jump over many nodes using extra layers. Now, let's talk about the performance. The average complexity for the skip list is very good. And the first thing is search, big O of log n, which means even if there are thousands of elements, you only need a few steps to find one, right? And the next thing is insert or deletion. It also big O of log n. So adding or removing items is also fast. And the third thing is space. This is a big O of n, meaning it uses the spaces proportional to the number of items stored, plus some extra for the higher levels. Finally, where do we use the skip list? There are very popular in database and in memory key value stores like Redis, because they can handle the large amount of data efficiently and allow very quick lookups and updates. So in simple terms, skip list are chosen when you need speed with simplicity, faster than linked list, and easier to maintain their complex trees. And the next thing is, now let's understand the structure of skip list. Skip list is made up of multiple levels. At the very bottom is level 0. You have a normal linked list that contains every element. This is the slowest level because you have to go through the each node step by step. Above that, we add a higher levels like level 1 and level 2 and so on. Each higher level contains only some of the elements from the level below, right? There are shortcuts or express lands that allows us to skip over the many nodes at once. Each node in a skip list has forward pointers, which allows it to point to the next element in the particular level. So the more level of nodes appears in, the more pointers it has. Okay, let's just look at the example here. Level 0, it contains all the numbers like 1 to 9, and the level 1, it contains a fewer number like 1, 3, 7, 9. This lets you skip over the sum elements, and the level 3 it contains even fewer 179. You can make big jumps, right? When searching, you start at the top level, move across quickly, and when you can't go further, you drop it down to the next level. This combination of jumping and dropping down makes searching, inserting, and deleting very fast. So the idea is simple, like more level means more shortcuts, and more shortcut means more faster operations. Okay. And the next thing is, every single node is designed in a skip list, right? Each node is a bit more advanced than a normal linked list node. In a linked list, a node stores just a value and a single pointer to the next node. But a skip list, a node needs to support the multiple levels, so it must hold. And the first thing is the value or key, the actual data we want to store. And the second thing is an array of forward pointers, one pointer for each level in which this node appears. For example, if a node is present in 3 levels, it will have a 3 forward pointers, one for each level and the next node. In the code is here, you can see how it written, like struct node open curly braces int key, and the next thing is node start forward of max value and the close curly braces. Here max underscore value is the constant that defines the maximum number of layers a skip list can have, right? Each node's forward array will be as long as number of levels it appears in, and unused pointers can remain null. So think of the skip list. So node is small box with a value inside the multiple arrows, like pointing forward. Each arrows belonging a different shortcuts land. Now, let's see how we insert a new element into your skip list with an example. Suppose we want to insert the number 6 into our skip list. How do we do it? This first step is determine how many levels this node will appear in. This is done using a random function. Why random? Because skip lists rely on probability to keep the structure balanced. Sometimes a node will appear in just one level, sometimes in more. This ensures efficiency on average. Next thing is, once we know the levels, we insert the new node at the appropriate level. Look at this list before insertion, and the level 2 it contains 1, 7 and 9, and the level 1 it contains a 1, 3, 7 and 9, and the level 0 it contains a 1, 2, 3, 4, 5, 6 and will be added as 7, 8 and 9. At the base level of level 0, we place the 6 in its correct position between 5 and 7. If the random function also gave it level 1, we added another pointer at the level connecting, like 5, 6 and 7 and so on for any higher levels. So insertion is the skip list means find the correct position and decide the levels, and also then link with the new node properly at each of those levels. Now let's see, after inserting a element 6 at the level 0, which is the base linked list, we can see the 6 has been added between 5 and 7. So the sequence now is 1 2 3 4 5 6 and 7 8 9, right? At the level 1, the random level chosen for 6 made it appear here too. So now it's 1 3 6 7 and 9. This allows us to skip even faster when searching. At the level 2, the highest level, like nothing changed because 6 was not chosen to appear here. It still remains like 1 7 and 9. This shows how insertion works in a skip list. The new element is added to all the levels that were randomly selected, and it maintains a sorting order at the each level. The higher level, it's a fewer elements, so the higher level it helps to speed up to the search. And so now when you search for 6, you will first move quickly through the level 2 and level 1 and then drop down to find the level 0. This is the power of skip list, for fast navigation using multiple shortcuts. And the next slide is search operation. Now let's learn how searching works in a skip list using the example of finding the number 6. We always start at the top left node, which is highest level first element. From there, we moved forward along with that level as long as the next value and is less than the target. The moment we are about the overshoot, meaning that the value is bigger than 6, we drop down to the next lower level. At the new level, we continue the same process, like move forward, stop before overshooting, then drop down again. Finally, when we reach out the base level, we either find the number or confirm it's not there. This method is very efficient because we skip over many elements at higher levels before dropping down. So instead of checking every single node like a normal linked list, we quickly narrow down the search. This is why searching in a skip list usually taking only about big O of log n time, which is much faster than a big O of n in a regular list. And the next slide, let's see how deletion works in skip list with an example. Suppose we want to delete the element 3. Deletion in a skip list is similar to searching but with a one extra step. Like first we start at the top left node and move forward at each level until we reach the position just before the node to be deleted. Like each time we find the node, we adjust the forward pointers to skip over it. This ensures that the node is removed from the every level in which it is appear. Look at this list before deletion. Like level 2, it contains 1 7 and 9, and the level 1 it contains 1 3 6 7 and 9, and the level 0 it contains 1 2 3 4 5 6 7 8 9. At the level 1 and level 0, the number 3 exists, so we update the forward pointers of the previous nodes to bypass the 3 and point to the next node. At the level 2, 3 doesn't exist, so no changes are needed. By doing this at every level, 3 is completely removed from the structure. So the key takeaway is to find the node at each level, like adjust the pointers to skip it, and if the deletion is to completed. And the next slide, after deleting the element 3 in the level 2, it contains 1 7 and 9, it is unchanged. And the level 1, it contains 1 6 7 and 9, so 3 is gone, right? Level 0, 1 2 4 5 6 7 8 9, 3 is removed here too. The important point is to has been completely removed from every level where it is exist. These forward pointers have been adjusted to skip over 3 and directly point to the next node, right? This demonstrates the main strength of the skip list is searching, insertion, and deletion are efficient because we only adjust the pointer in few places, not the whole structure. Okay, so after deletion, the skip list remains sorting and ready for the further operations. Now let's see the final output of our skip list operations. We started by inserting the numbers like 1, 3, 6, 7 and 9. Later we also inserted 4. Since skip list work with multiple levels, like each number may appear in one or more levels depending on random level selections. After all insertions, the skip list looks like this, like level 2. Level 2 is the highest level. It contains 1, 7 and 9. In the level 1 it contains 1, 3, 6, 7 and 9. And the level 0 it is a base level. It contains 1, 3, 4, 6, 7 and 9. When we started for 4, the algorithm starts at the top left node. It moves forward and when it is overshoot, it drops to the next level. Finally, at level 0, it finds the number 4. If we delete 7, the node is removed from all the level where it is exist. The main idea is that skip list makes searching like insertion and deletion much faster by skipping unnecessary node at higher levels. And now let's see the advantages and limitations of skip list. First thing is the advantages. Skip list are much faster than normal linked list because they allows us to skip over the large portions of list using higher level pointers, and they are easier to implement compared to balanced trees like AVL or red flag trees, because there is no complex rotations because we just rely on random levels. And the limitations are they use a more memory since each node may store multiple forward pointers across levels, so the randomized level assignment can be unpredictable. Although it is usually works well, performance can vary slightly because of the randomizations. So skip list gives us to speed and simplicity, but at the cost of extra memory and some randomness in structure. And the next slide, to wrap up, let's summarize the skip list. It is a basically layered linked list with a random leveling instead of scanning every element like a normal list. We maintain the multiple layer that let us skip over elements, making searches and insertions and deletions faster. It is a fast and probabilistic alternative to balancing a tree, and you don't need to complex rotations or balancing. But you still get near logarithmic performance most of the time. Skip lists are very useful in real-time search scenarios such as memory indexes or online systems where speed matters. Finally, the best way to understand the skip list is through practice. Try insertion, deletion, searching and tracing how pointers are updating. This will make the concept much clearer. Thank you.